In the previous video, we talked through step one of our 6-step process of testing claims and using the scientific method. We walked through some examples of testing, or we're not testing yet, we're setting up the null and alternatives for statements such as, a politician claiming that the mean income is at least 52,000. The chopstick example, we wanted to be able to test whether or not our chopsticks were coming out at 10 centimeters. We looked at somebody making a more kind of outlandish claim that the mean height was only 5'2" on campus, and then the last one, or the orange one down here, that OJ is innocent. So obviously we're not going to test that with our methods, but we'll turn to that here to kind of discuss what we're going to do next. So in step two, we are going to select a level of significance, and this is up to us as analysts or on the production team to decide what level of significance we require. And really what we're choosing is how much evidence do we need to reject the null. Okay, so again, we're setting up the null hypotheses as a statement that we are then going to test. And of course, whether or not we think that we can reject the null is based on how much evidence we find. And so a way to think about that is, again, thinking about the OJ situation. And so what do we say in criminal court? We say they are innocent until proven guilty. And how do we decide if there's enough proof, enough evidence to suggest that we're going to reject the null and go with the concept that they're guilty? Well, we have terms for this. So we say things like beyond a reasonable doubt. Okay, so our level of significance for OJ is I'm gonna switch to a different color. Our level of significance that we use, and I'm gonna label this as alpha. Our level of significance is beyond a reasonable doubt. And we have set that up beforehand, right? We do that before the trial, and in fact, we use the same level for every criminal trial. But that's important that we don't say, okay, OJ's innocent, and then we look at a bunch of evidence, and then we say, well, here's enough evidence, or what am I trying to say? We don't look at the evidence and then decide how much evidence we need. Okay, we need to set that standard of evidence before we turn to actually looking at the evidence. Okay, and so we say we're going to treat OJ as innocent unless we find enough evidence that it's beyond a reasonable doubt. And so again, if you're familiar with the case from 1994, and again, just to put it in the context, this is one of the main reasons why the Kardashians are famous. So hopefully that helps you refresh as to who I'm talking about. If you remember, it was found that there was not enough evidence. It was not beyond a reasonable doubt. Now we could go on a deep dive about how much evidence there actually was and whether the jury had other issues there. But let's take the jury at their word. They found that there was not enough evidence beyond a reasonable doubt, and so it did not reach the level of significance to reject the null hypothesis. So we maintain and we stay with OJ as innocent. Now, in a similar sense, or related to this, is what if we had a different level of significance? What if we said it's not beyond a reasonable doubt? We're going to use some other level of significance. And another way to kind of think about this is maybe how high of a bar do you need to get over? Kind of like a high jumper needs to get over a certain height of bar, right? And so we might this is probably going to go poorly, but there's some, probably give them a mat to land on. And there's some level of significance, and depending on the height, that's a harder level to get on. Okay, so beyond a reasonable doubt might be this higher bar. We might try a lower bar, something like the preponderance of evidence, which is another alpha. So alpha of the preponderance of evidence and this is the level that we set in not criminal but civil cases. Okay, so again, if you remember, or if you watch the Netflix documentary, I didn't watch the end, so I don't know if they go into this, but the civil case, OJ was in fact found guilty. So at this lower level, so maybe the lower bar here on our poorly drawn landing high jump, what is this thing? High jump pad. The evidence was enough to get over that level of significance. Okay, and so the lower level of significance, OJ was then found guilty in the civil case in order to pay however many millions of dollars. So the level of significance is important, and we are going to choose that for our other more testable hypotheses up here. Okay, so let's set OJ aside for now, but hopefully that kind of gives you a frame of reference as to what we're talking about in terms of level of significance. So really we're setting the bar of how much evidence do we need. Now, what's going to be more familiar than legalese terms of preponderance of evidence is the percentages that we're going to talk about here. So we talk in terms of levels of significance in percentages. So we will use things like a 0.05 or 5% level of significance, or 10% or 1%. And these are going to feel very familiar, and in fact, they are directly related to what we've just been working with, which is the confidence interval. So let me just okay. So let's actually, I'm going to grab this and bring it with. So of course we don't have the terminology from the court case, but what do we have for something like our chopsticks example? So how are we going to decide if there's enough evidence? Well, we're still going to use alpha. Okay, so we're going to stick with the term alpha, but this time we're going to use maybe 0.05, okay, or 0.1, or sometimes 0.01. Okay, these are the most common levels of significance, and these are directly related, or we're going to be using the same z and t values as, say, 95% confidence interval. Okay, these are going to feel very familiar, and we're going to find these values right in the same area as we did for the confidence intervals. Okay, so when we go to the t-table, you notice the first time we kind of set aside some of the regions on the t-table we set aside. We just focused on confidence intervals. The areas that we left aside were these levels of significance. Okay, so that's largely where these are going to be taken from. So we're going to be able to find 5%, 10%, 1% confident or levels of significance directly from the t-table and the z-table. So why do I say the 5% is like the 95%? Well, a couple things. So first, I want to recall that we are talking about what we call a two-sided test up here. Okay, so this is a two-sided situation in that we can look for evidence either below or above the mean being equal to 10. Okay, and this is different than, I'm going to flip back, this is different than our one-sided example up here. Okay, so the income question is a one-sided test, and we'll get to that a a little later. But on a two-sided test, that means that we are looking for evidence on both sides of the distribution. Now, how we are setting this up is that we are assuming, again, we're always going to give the benefit of the doubt to the null hypothesis. So in our case, we're assuming the mean is 10. So if the mean was 10, do we find enough evidence that it's not? And the way we are going to find evidence, again, is via a sample. And so we're going to look for evidence, that being samples that are either really far above or really far below. And basically, we're going to say, is this rare enough that we have enough evidence to reject the null? So that's why it's two-sided. So why is it 5% and not 95%? Well, back in the confidence interval case, we were dealing with the inside part here, right? We were trying to give a window to the above and below our value, our best guess. So we were talking about values close to our value or to our sample mean. In our case here, with a 5%, we're interested in the extreme cases. We're interested in, is there enough evidence that it's too far away? Did we find a sample value that's so far away from the mean, or our null hypothesis mean, that we can reject it? And so we're talking about the extremes. So that's why it's a 5%, but the value here, the cutoff value, is the same, right? So at a 95% confidence interval is going to give you a certain z-score or t-score, right? Z-score would be the 1.96, the t-score, depending on the sample size. Similarly here, a 5% confidence interval is going to give you that same cutoff. We're going to have a z-score of 1.96, or again, it would be the same t-score if we had the same sample size. So that's why I say they're kind of directly related. And so to bring it back, we have to decide what level of significance, right? So just like is it a civil or a criminal case? We have to decide, is it a 5% or 10% or 1%? Most commonly is the 5%, just like we said, most common was the 95% confidence interval. But you will see it, especially depending on the kind of the situation that you're talking about. So, it depends on how precise we want to make sure we are with our production here of chopsticks. Maybe we're a little loose about it. We don't care if it's off a little bit. So those are decisions that you have to make, but you want to make it before you get to actually taking the sample. Okay, so this is the time in which you should be deciding what level of significance is enough evidence to reject the null. Now, briefly, I do want to mention, if we are talking about a one-sided test, the same process happens here. Let me just grab this quick. So we are, let's plop it over here. We're going to be dealing with the same situation or the same kind of concept, but we want to deal with. So we're testing the claim that this is 52,000, or that, yeah, the mean is 52,000, or at least 52,000. I slipped up there. So it's at least 52,000, which means all of this is okay. If we take a sample and we find 79,000, that does not give evidence against the null hypothesis. In fact, that's included in the null hypothesis. So the only part that we are able to say is evidence against the null is, of course, things that are below 52,000. Now, we're kind of jumping ahead of ourselves a little bit, but obviously, or maybe not obviously, but if we take a sample and we get 51,980, we know from our work on sampling that the sample can jump around a little bit, right? So sometimes we have a sample that's a little bit below, sometimes a little bit above. So if we get a sample that's $20 off, if it's $20 below 52,000, that's not enough evidence probably to say that the mean is not 52,000, right? The true mean isn't 52,000, because again, all we're going to do, again, we're kind of getting ahead of ourselves, but the mean that we take is really going to be a sample mean. right? And we know that it's not exactly the population mean. So what I'm trying to stress here is that we need evidence, enough evidence. So simply getting a sample mean a little bit below isn't necessarily enough evidence. So what we're looking for are those extreme cases. So clearly, if we get something like a sample mean of 14,000, that's likely to be enough evidence. So what we're looking for here, though, is what is that dividing line? Is it 42,000? Is it 44,000? Is it $41,326? But when we get out into this window, the bottom 5%, right? So we think about this as a distribution. The bottom 5% would give us enough evidence if we've set alpha at 5%. Okay, so that's going to be a little different of a calculation because this is 5%, but if we zip back over to our two-sided test or two-sided situation here, this is not 5%, this is 2.5%. Okay, and this is 2.5%. Right, so those critical values, the dividing line is going to be different in a 5% test depending on if it's a one or two-tailed test. So when we set up our null and alternative, we're thinking about, does it include greater than or less than, or is it just simply this type of a situation where it's equals to 10 and not equals to 10? And that's going to dictate where we kind of go, we're going to need to keep that in mind when we turn to levels of significance and then future steps as well.